Hey guys, I'm going to be showing you how to set up VS Code with the Alpaca library. And I'm going to assume you know at least a little bit about C++, maybe even a little bit about how the compiler works, and how we go from our source files to what we need, which is in this case a shared library, so that the Alpaca client can then consume and use it to run whatever script we may write. So I'm going to jump right in and start kind of from the beginning. What you'll need is the Alpaca client and the Alpaca library. They are conveniently hosted in Git repositories, which there's a lot of really neat things you can do with Git and integrate it with these, but I'm not going to really show you that. So what you really need right now are just the files. So I would just recommend getting them in a zip format, get both the library and the client. Once you have those, you can extract them, and they can really be anywhere. It doesn't matter. These locations really don't matter. But what you need to do first is you need to open the Alpaca client at least once, and the reason for that is once you open it once and let it set up and everything, it will create a folder in your user called AlpacaBot. So you can see users, user, AlpacaBot. And this is where it keeps all of its data, such as the scripts, the players you make, the cache. So you can keep the library and client anywhere you want, but I honestly like them to be right in here with everything else. And I will rename the folders just clients and library. So that makes it really easy for me to see. It keeps it all in one place. It's very basic. So once you have those two things and you have the library, the client, and everything you need, you will need to get the compiler. Um, You can grab that from, there's a development environment setup thread to grab that. It's the link is right here. It's mingw, and this is a cross-platform compiler, so that you can write with you can write cross-platform. You can write portable C++ code. Ironically, these scripts will only work on Windows for now, but that's the compiler we need. So once you download that, you should probably just place it on your C drive. That's the easiest place for it. It's simple. That's what the development environment setup guide does, and that's what I do. So once you have that, you'll notice in the bin directory of the compiler will be a ton of executables, and these are what we need. Well, one of them is what we need to compile our scripts, and we need to compile it using 32-bit, so we'll be using these. So for the command line to get easy access to these executables, we're going to need to add this whole folder as an environment variable. So what we're going to do is we're going to get to our environment variables. Pretty easy on Windows 10, but other systems will vary. And once you're in this screen, you'll want to look at your system variables. So we don't want this to just be for user. We want this to be for the entire system. So we're going to edit this. And as you can see, I already have it added here, but generally you'll hit new and you will add a path to your bin folder in your compiler. So once you have that, you're all good with the compiler and the library. So now we can go right into VS Code. So when you first open VS Code, you'll see a welcome screen sort of like this. And I don't know everybody's experience with VS Code, but it's not an IDE. It's a very feature-rich text editor, basically. It really doesn't support C++ natively, but we'll get to that here in a second. But the general key here to know is that there's no concept of projects. There's no concept of settings for projects. It's kind of more about workspaces. And workspaces is just basically a collection of folders and files. These folders and files don't have to be in any set directory or anything. You can create a workspace for anything, for any number of folders and files. And you can also create a workspace that has folders and files from another workspace. They can overlap. It's very flexible. And you can have settings specific for each workspace, but they're all self-contained. It's very lightweight compared to what an IDE would do. You can also open individual folders, and you can work in Visual Studio Code without even needing a workspace technically. So what we're going to do right now is, the first thing we need to do is make VS Code work with C++. So I've already installed this, but basically what you'll do is you'll search extensions in the marketplace, search C++, and you'll find this, which is an extension made by Microsoft that gives VS Code the ability to read C++ and provide IntelliSense, properties for debugging and compilation, and all sorts of nice features that you might get with working with C++ in a full IDE, all based on this one extension and code editor. So once you install that, you'll need to reload Visual Studio. It'll give you a button for that. So once that's done, we can go into our open folders and files. So the first thing we want to do is open a folder. So let's create just a temporary script. So I like to keep everything in one place, like as I said. So I'm going to add a workspace to this, and it's just a workspace folder where all of my coding will go. And let's make a folder for a script. So we'll call it demo script. And I will then open that folder. So workspace, demo scripts, and Visual Studio will briefly reload and you'll see demo script here. Now, I like to add a workspace to keep all of my projects kind of contained in one file. So what I like to do is if you go to, I didn't quite show you that, go to File, Save Workspace As, we'll call it Alpaca Scripting. And what that's going to do is it's going to save a file in your workspace folder called alpacascripting.codeworkspace. And basically, while you're working in this workspace, you can add as many folders as you want, any files you want, and this file right here will tell Visual Studio Code what files and folders to keep kind of in here and what settings to apply when you're working in that workspace. Generally, I only add folders and files that are contained within this folder just for sanity's sake, but it's pretty flexible. You can do whatever makes sense in your head. So now that we have our script and our setup, the first thing we need to do is create a file. So we'll go with main.cpp, and you got to put your own extensions in here. I like to capitalize my file names, but whatever makes sense for you. There's really no hardcore standard when it comes to this stuff. So now that I have that, we have a blank file. It's almost like we're working just directly into a text editor. I'm going to do one quick thing right here. I like to have autosave on, so I'm going to enable that. That's just file autosave. So I'm going to pull over a snippet from here, which is just a skeleton of a standard script for AlpacaBot. So as you can see, it contains most of the normal stuff here you would see in any skeleton for a script with the loop on start and setup. But we have the squiggly line here because Visual Studio doesn't know what that is, but it detects that we're using a C++ file. So it wants to help us by creating an include path setting. So when you do that, you would hit edit include path setting, and it will create this directory for you called .vscode. This is the settings for this folder, basically. So if you go in here, it creates a ton of stuff for you for C++ so that the C++ extension can then use IntelliSense on whatever you're working at for whatever operating system, so Mac, Linux, and Win32. Well, we really don't need all of this. It includes some stuff from Visual Studio Windows kits to develop on Windows 10, but we really don't need any of that. What I'm going to do is I'm going to copy over another snippet I have, which is just a configuration for Windows. So we can see the name is Win32, which means, compile for Windows. And let's clean up some of that. It's a little messy. Okay, I think I got it. So this looks probably a little similar to what it auto-genned, but instead of using all of the Microsoft stuff, we're using the MinGW stuff. So as you can see, most of the include paths come from the MinGW 64 directory, which is our compiler, and this tells the C++ extension where to find all the header files for IntelliSense for like the standard library and all of the other things that are included automatically with this compiler. So that's basically all of your normal C++ stuff that you don't need to go download another library for. I've also included the AlpacaBot library, which is in this location as I moved it to earlier in the video. So what you need to do is just make sure that that include goes to wherever you placed your library, and it has to be this folder. So it has to be, that's not the right one. It has to be this folder, the include folder. And this is how the IntelliSense knows to, when you write code that references Alpaca, it will not throw you any warnings. It will give you autocomplete. It will actually help you code for it. Some other things I added were these, which there are some bugs in VS Code that prevent certain techniques in C++ from being recognized. These will just generally help you recognize it. I think, like, for example, this didn't recognize certain ways to initialize a vector. This helped it find include paths to C libraries. So a lot of the standard library with C++ goes back and references C headers and C objects. So we need this to make sure it doesn't error out when we try to reference one of those. Well, it won't error, but it will try to tell you it's wrong. This will make sure that that doesn't happen. The browse path is mostly including some of the stuff that we saw in the include path. There's a difference between these two, and you can go look that up, but just know that we generally need all of this. I'm going to include a snippet for this, by the way. So now that we have that, we can see that we get no errors, and we can actually start coding. We can use like the internal namespace and game object and stuff like that, if I spelled it right. So we can use it. It doesn't throw any errors. It actually sees it. But that doesn't really help us compile it. Just because it can see what we need to do doesn't mean it knows where to find it. So once we have the IntelliSense working, we need to tell it how to compile this script. So the next thing we're going to do is we're going to configure a task. So if you hit Control-Shift-P, what happens is the command palette goes up. And the command palette is Visual Studio Code's toolbox here to do anything you might need to do. It gives a lot of terminal access, viewing, finding stuff, all sorts of things. So we're just going to type in tasks, and we're going to just configure a task. We'll just do a regular task. So we'll create a JSON task from template for our demo script. And we don't need any of these, we just need others. So that's going to create a task in the same directory it created our properties. Remember, these are only for the demo script folder. They don't go to anything else. So once we have our tasks, this tells Visual Studio Code something to run, a command. So if you've ever compiled C++ or done anything with C++ through the command line, this is kind of similar, except that we're going to automate it. So I have a snippet for this already, which I will provide. This will make it a lot easier. Generally, building is going to be split into two tasks, actually. So let me walk you through that. So we have this first task here and this second task. Right now, the first task is called build script name objects and then build script name. So when you compile a C++ program, we need to first compile the objects and then link the objects to the actual library and, you know, output DLL or whatever we need to output. So that's why it's in two tasks. The first task can be ran on its own, but generally what we want to do is run this task and then this task. Visual Studio Code has a nice way of doing that by first of all letting you define a default build task. So when we press Control-Shift-B, it will automatically run this task right here. You can't run this task without first running this task, or at least it'll fail if this task hasn't been run before. So we use this nice depends on property to make sure that this task runs before this. So when you run this task, it'll say it depends on this one up here. So run that one, then run this one. So that will eventually end up building your script. So let's go through kind of what each one does. So first of all, we're going to build the objects. So I'm going to kind of replace script name with demo script here. and the type is shell. So automatically, what VS Code normally does is use Windows PowerShell to run its commands. If you're on Windows and have access to the PowerShell in any way, this is the best way to do so. PowerShell is very powerful, and although we're only using it for a basic command right now, you can add as many tasks as you want using your knowledge of PowerShell to do all sorts of cool things. But I won't show you that in this video. We're going to keep it very simple. So our command is this executable right here, which is the G++ executable, our compiler for 32-bit. And the reason why we can just call the executable without telling the Visual Studio Code or our PowerShell where it is because we set that environment path earlier. So that's what's going to compile it. Second, we give it arguments. A lot of these arguments are provided through the development setup thread I showed you earlier in the video, but I'll walk you through a couple of them. This M32, or let's start with the top, I guess. This argument tells the compiler that we're using the C++ 17 standard, which is the newest as of now, so we can use all the brand new features of C++ 17 that make it so great. This flag tells us that we are compiling for 32-bit, plain and simple. This is just a define for the build DLL. I'm not entirely sure what that does. It has something to do with the fact that we are building a shared library. The wall treats warnings as errors, I believe. It shows you all the warnings. So there's not just errors with the compiler, it'll also give you warnings, things like if you're writing code in which you could lose data through conversions, it will let you know, and this will make sure that it really lets you know. This is an optimization flag. It'll just make it compile faster in most cases. I wouldn't worry about it too much. This is important. This is kind of where it really comes into play here. This I flag tells you where to find the include path. And the include path is how the compiler knows that the code you wrote actually goes somewhere. It tells it, where do I look for the code you've been writing? So we include the AlpacaBot library include directory. So that way when we write things like game object, it goes here, goes to include, finds the game object header file, and it knows that it exists, and then it compiles correctly. This is all we really need for include, but if you were to include any other libraries, it would go here. And to do that, you would simply just do the same thing as you did with the top one, and then path to include directory, whatever you need to do. But for now, we don't need that. This flag just tells it to compile, not actually output anything. We're just compiling the object files, which is why we named it as such. So here's where the source file goes, and this is kind of a downside to Visual Studio Code, and you can automate this, but you would have to build something you would have to build your own solution. So we need to tell it what files to give to the compiler. So right now our only file is main.cpp. But if we added files, we would need to also include whatever other files we need to be in our script. But for now, it's just main.cpp. This matches it with the GCC compiler, not too important. So now that we have our compile task, now we need to do our linking task, and this is equally important. So we're going to call this one, since this is our last task in the sequence, we're just going to say this is our build demo script task. Because it depends on the building of the objects, it will always run this task when you run this task. You can't run this task without first running this task. It'll do it automatically if you don't do that. So again, it's a shell command and it's the same executable. And I'm going to show you what I normally do as the output path. So instead of just having an output to its normal directory, which would be where you're writing the code, I actually have it compiled directly to wherever I want it, which is in the scripts folder in the local. So I'm going to say demo scripts, and I'm going to copy that. And then I'm going to do demo script.dll, and that's where I want it to compile to. So that way, when I hit this task, once it's finished, I will have a script in my local folder ready to run right there. So I don't need to do any moving of files or anything like that every time I build a script. So let's go through some of the arguments again. This kind of just tells it it's it's static linking. It's linking to a static object, which is what the Alpaca library is. M32, same as the other one. I don't actually know if you need these on both of them, but I do for whatever reason. I haven't tested it. So this is quite similar to what you saw up here with the include. The include directory tells you where to find the definitions of the things you're calling, such as, the Alpaca library game object, any of the classes you find in there, but the actual code within the library needs to be found, and that's where you find in this directory, which is the library. And if you actually go there, all you'll see is a libalpacalibrary.a file. So what that is just a big compilation of all of the actual object code that has been created by that library. But we need our linker to see that so it can actually match it to what we've written. So all you need to do is do this L flag right here, and then right after that, you don't even need a space, although I think you can, but you would have to put it on a new line. You can put the path to it. So that's the path to mine, pretty plain and simple. Once you have that, it's the same thing as before, though. If you do any other static libraries, you would include it right there with the same syntax. The shared tells these two commands will make sure that it outputs to a DLL. It's not building it, it's linking. So we need to output it as a shared DLL. Now we need to do the object files. So this is another kind of pain that we have to go through with VS Code that we might not have to go through with other IDEs, and that is linking the objects manually. So for every CPP file you have, you need an object, and it's pretty simple, just main.o, because when we compile it, that's what we're going to see. That's what we need to link to. The way I do it currently and the way I'm showing you here, when you build the object files, they're going to be right in the same directory as their source files. So when you build main CPP, when you compile it, it's going to produce a main.o file right in the same directory, so you can just reference it like this. By the way, you also have to put any header files here as well, but header files do not produce object files, so they don't need to go here, just the CPP ones and the respective folders. So once you do that, you need to link these object files with the Alpaca library, so we include this right here, and that just says look in this directory and find the Alpaca library file and link it to whatever needs it. And it has a weird syntax. Basically, this command tells it look for Alpaca library, strip the lib part of it and strip the .a, and you kind of have it. If you have a library, for example, that doesn't have lib or anything before it, you can actually specify a specific directory, but I won't get into all that right now. And we're going to set this one as the default. So once we have that, we should be all good to go. We can actually build it. So if I hit Control-Shift-B, which is the default build task, it will first run the build objects task, and then it will run the build task. So you can see this task was ran, and then this task. You can also go here and run build task. That's kind of what I did with the command. Or you can run that from here. So you have, if you go to run task, you see that you have these two tasks configured, the build demo script and build demo script object. So you can run this independently. There's no real reason to. It's just easier to hit this one. And then once it's done, it'll keep using this library. You can space out of it if you need. But if you go to your scripts folder, go to local, go to that folder, you can see it right here. And that's how you can use it directly from the Alpaca client. So that's how you generally set up VS Code with AlpacaBot. Now, there are also more things you can do with that as well. So instead of copy and pasting this every single time, we can do what's called snippets. And I'm not going to go into that right now, maybe in another video, maybe in another thing, but just know that there's no reason to copy and paste all the time. There are a lot of cool features within Visual Studio that make this easier. This isn't the only way to configure this. Visual Studio is very flexible. There are many ways you could do this. You can write your own PowerShell commands. You can write your own batch scripts, PowerShell scripts. For any kind of build you want to do. You can even use what's called CMake with Visual Studio if you prefer that, if you've ever used CMake before, which is a cross-platform make tool for C++. It's really not necessary here. It carries a lot of extra baggage, so I won't go into any of that right now, but this is just generally the bare bones what you need to do to create a script with Visual Studio Code, and I hope that helped. Thank you.